Okay, then let's start with this 18 and 19 number for the slides. So previously we were looking at the supervised learning, and then we saw the two categories of this supervised learning: classification and regression. And now here unsupervised learning, and we know that unsupervised learning is an opposite of the supervised learning, which means we don't have pre-labeled data for the training of the model. So here you can say that we have only the data with apples and oranges, and we don't have the names for these images. So this is the raw data we have. We don't have labels. Previously here, we have labels for the data. So we have this data which is labeled. And what means labeled? It is mentioned here that this would be rectangle, this would be circle, this would be triangle, this would be hexagon. The names of the figures would be there. So these names are called labels. But here we don't have any names. So that is unlabeled data. But we will provide some interpretations for this data and then we will give this algorithm will take this data along with the interpretations. These interpretations can be features. We will see next. We will explain, we will describe this data. What are the properties of this? What are the properties of this? This is called interpretations. Algorithm will take this and it will process, and this we don't need any test data because this is non-labeled data and we have to categorize them. So that's why after processing, this algorithm will process that data and it will separate the apples and the oranges without taking any label. So we don't have any pre-labeled training data. And the techniques for that, we can use k-means clustering, we can use k-nearest neighbor, etc., many others. So this is the slide now from where we have to start. So unsupervised learning has 4 subcategories under it. The first one is clustering, second one is association, then dimensionality reduction, and the fourth one in anomaly detection. All these 4 are the subcategories of the unsupervised learning. This clustering would be very much similar to your classification here. Here you have 2 classes, SPAM and not SPAM. So this clustering would be similar to that. Like you are seeing here, we are giving this data with different people, and we are making groups of the people by their behavior. So we are grouping customers by their purchasing behavior. So what is clustering? As it is an unsupervised technique, so it means the data that we will give, we will not have any labels for that. We will not have any labels for that. And we have to, and this is a mix of different things, and we have to separate these groups. But how we can do? So we can find some kind of a similarity or relationship patterns, or you can simply say relationships between these data samples. So this one is a data sample, another is data sample, another is data sample. So you can do what? You can find the similarity or any kind of relationship. Any kind of relationship. So, and based on these similarities or relationship, you can group them. You can group them, which means you can cluster them. Cluster is like a group, huh? Synonym of cluster, group, same thing. So you can cluster them, you can group them. And this is the example here that if we have the customers, we can make their groups, we can make their clusters by looking at their behavior. This behavior can be any behavior is just how the customer is behaving on internet. Maybe some customers are searching too much before buying the actual thing. So this is one behavior. Another behavior is some customers are uh, finding too many different, searching too much on, for example, one is searching too much on one specific website, another is searching too much on many different websites. So this is another behavior. Another behavior is some customers are looking only few things and then they are buying something. So or so so these can be different behaviors. Or some customers are logging in and without seeing anything they are buying directly. Some customers are buying only cheap things, some are average. So these are different behaviors. So based on this behavior, you have these groups. So this is called clustering. And how you can find that clustering? By finding the similarity, or if there's no similarity, then you will find some relationship between relationship between the data samples. So they have the same relationship. Similarly, they have the same similarity or relationship, like that. Number two, association. And clustering is also a technique. Okay. So how you can do that? K-means clustering is one technique you have seen in the previous slide. So you can use this K-means. It is available in Python libraries. You can use it directly. You don't have to do that. It will do that directly for you. And then K nearest neighbor, based on the similarity, it will find the distance between the two things and finding the nearest neighbors. So anyhow, so these can be the two examples for that clustering and many more. Another one, second one is association. So again, association, the name itself is giving you an idea that you have to find some relationship that would be associated between two things. The name itself, associated normally means what? So one thing is associated to other thing. What it means? They are linked with each other. They have relationship with each other. So association again, you can do what? You can analyze large data or data set, whatever you want to say. Data set. You can analyze, you can see, you can observe, and you can find some pattern in it. And those patterns will have some relationship between different things. Between different things. So now you can imagine that you have a data, and from that data, you have to see different things. In the data, you have different objects, you can say, or different entities, you can say. And then you can find the similar concept. You can find the relationship between them for analysis, not for grouping them, okay? Not for grouping them, but for doing some decision. But for doing some decision. For example, here, you have the data of people's our customer sales, and then you can say that from that data you can say that customers who are buying some item X, they they are also buying some item Y, or they can also buy the item Y. This is the evidence present in your data that you have analyzed, So you analyze the data set and you have found from it that the customers who are buying X are also buying item Y. So this is the relationship, this is the association that you have found from the data. And You also seen this evidence that the customers who are buying item A plus B, they are, they can, or they are also, some evidence is present there. So that's why you can say they can buy the item C also, which is mentioned here. The customers who are buying this coat, they can also buy the boot. The customers who can are buying this milk and bread, they can also buy the cheese. This is the evidence is present in the data. The evidence is present in the data. And this is called association, that this is associated with this. This is associated with this. And if you are running some kind of a business, then you can, then this association uh, category of unsupervised learning will give you the benefit. Then you can increase your business by finding this by finding this association between them. So what are the techniques? Association rule mining are simply called ARM. Are so this is the technique you can apply, and this is available. This is available in Python libraries. You can also call them market-based analysis. So this is a market-based analysis, huh? Mostly this association will so association rule mining, this association rule mining is basically called what? Market based analysis, other name. So you can do this association rule mining uh, in the Python libraries, which is available already. It is already built, and you can just, you have to call them and you have to give your values, and then that will do the things for you automatically. Number three are dimensionality reduction. I already told you that dimensionality means, our dimension means size here. Here in machine learning, it means size. Size. So dimensionality reduction. Reduction is from the word reduce. So you have to reduce the size of something. That is called dimensionality reduction. So normally when we have data at some point in future, you will extract features from those variables like this. This is unsupervised. So this interpretation, okay. So this is the raw data, and you have done, you interpreted this data, or you described this data. So this interpretation, it is in the figure. So that's why you don't know what is the detail there. So sometime if you have the raw data, you extract or you design features of that data. And what is a feature? At the moment, you can take, for example, if I will give you the table with headings and the values filled in all the rows and columns, then the column's name would be called what? Features. At the moment, for understanding, you can take this example, okay? Similarly, in future, when you will have your data, raw data, you have to convert that data into form of columns, and those columns can take values, and so then the heading of the columns would be called features, and you have to name them, you have to give these names to them. So anyhow, when you converted your data, or you designed some features for your data, and then you uh, uh, if those are the features, then you converted all your data under those features, under those features. But these column headings or these features, when you will design on the data, sometime you will produce these features too much. And if the number of these features would be too much, and then the values under these features, if it is millions and trillions, then you can imagine it will take how much computation time. So it will take how much computation time you can imagine. So that's why Dimensionality reduction is what? We have to reduce the number of feature variables, feature variable for each data sample, for each data sample. For example, here I said to you that this one person is one data sample. Here milk is one data sample, huh? So for each entry of data, that is called one data sample. For each data sample, you have to reduce the number of feature variables. Or shortly, too many features is not a good approach. You have to reduce the number of features. How we can do that? We will select, how we can do that? We will select only important features, and we will ignore or we will remove the features which are not giving or which will not have any importance. So we will do what? We will select only mainly or principal. Principal means also main, huh? Something which is fundamental. So you have to select only main features, or you have to select only principal features, which means only important features, and you have to make a set of that. So you, don't be worried with the word set, okay? So this all means that you have to select only important features. Why? Because if the number of features would be large, then it will take too much computation time. And this is a what? This is a curse. And this is the curse of dimensionality, or this is the curse of feature space dimensionality, which means this is the curse of size. This is the curse of the large size of large number of features. And we have to save ourselves from this curse. And how we can do that? There are different techniques available in machine learning. PCA, principal component analysis. This is one technique that you can apply to do this reduction. KNN, K nearest neighbor, discriminant analysis, DA. These are some popular algorithm to do this dimensionality reduction for you. How? What is dimensional reduction? This is just figurative explanation. Otherwise, it's easy to understand from these sentences. For example, if you are seeing here, this is a house, and here these are the different features for this house. Size of the house, some here, huh? Size is heading. Number of bedrooms is another feature. Number of bathrooms is another feature. Crime rate in the neighborhood is another feature. Distance to closest school is another feature. And if you have a data of houses, huh? And if you have data of houses, then these are the headings, these are the features. And this is the table, and you can imagine you have huge values. So then what? You can reduce this. You can reduce it, and you can take only important one. What is important? The you are taking the size, the covered area, size of the house, and then you are taking bedrooms, bathrooms. Why not you combine all this for one variable general size, huh? And you are taking, but you are taking only the general size, that this feet multiplied by this feet, huh? Similarly, crime rate in the neighborhood and distance to closest school, you are just from these two, you are converting them only into neighborhood quality. You are making another feature, neighborhood quality. So you are from these five, you are now finally have only two. And if you have a model for that, which is something which is what? Price of the house. And this is the house. And here small size will have the price. This is the house with lower price. This is a little bit higher, little bit higher, little bit higher, and these price is going in this way, in this way. And if you are performing some example like that, and now you can say only, now here you can only have a what feature? The size, the general size, and the general size, huh? Or something like that. So so in this way you can reduce the feature. In this way you can reduce the feature by yourself. Or if this is an image which has the x, y, or z positions, you can, here we have only x and y, z is removed, and here we have only y and z, x is removed, something like that. So you can reduce. Dimensionality reduction is what? Reducing the number of features. And then D, anomaly detection. What is anomaly? A rare event, an uneven event. Anomaly is what? An event which is rare. So now we have to find that rare event or uneven event, or event which is not in routine, not in routine. Something extraordinary will happen. So our model, when, so this is also a fourth category of unsupervised machine learning. So how we can detect. So this is a this is a diagrammatic example that if we have a aircraft engine features, aircraft, and then we have the data of different engines for the aircraft, and it has the feature. First feature is X1, it means heat generated, how much heat that engine is generating. X2, vibration intensity, something like that, and so on. So we have some, so we have an engine, and we can have different features for that engine, and we have a data set for different aircraft engines. Data set means which will have the values under each of these features. And here we have X1, one engine, second engine, third engine, and so on. And then here we are checking. We have a model, and that model will automatically detect anomaly from the data. And then we have a new engine now arrived, and now we want to check this engine, and this is the data X test according to that. And when you will plot this new engine on the graph, then you will, if your engine would be among if your engine would be among this set within the circumference of all the data set, if your data will lie here, either here or here or here, but within the parameter of the data, then this is not anomaly. Okay, this is okay. This is something that your new data, which is shown here as green, that your new data is similar to this existing data. But if your data, when you have this plot, and if this new data X is drawn here with the distance to actual parameter of this data, with the distance, then this is a rare event. Okay, this is called anomaly, and this is the visual evidence for that. This is called anomaly. So how we can detect anomaly? We can use k nearest neighbor, which can detect anomaly. We can also use clustering, because when you will test new data, it will not appear in the same group. Okay, this is a kind of a group, huh? This is a kind of a cluster. And if you have the new test data, it will not, if it is not appearing in this cluster, then it means it is anomaly. It is a rare event. So anomaly detection in unsupervised learning. So we use this anomaly detection to find out the occurrence of rare events or observation, rare observation or rare events. This is the fourth category of unsupervised machine learning. Moving next. We have seen supervised machine learning, we have seen unsupervised machine learning, and now we are moving towards the third category of machine learning algorithm, which is called semi-supervised learning. Semi normally means both, huh? In between. So semi Supervised means it is in between the supervised and unsupervised. It is in between the supervised and unsupervised, or you can say it is a mix. It is a mixture, or it is a mix of supervised and unsupervised learning techniques. So this would be neither fully supervised nor fully unsupervised. So it means that semi-supervised learning will take partially the concept of supervised and also take partially the concept of unsupervised learning technique. Look at this data and then you will understand everything. Here we are giving some data which is labeled data, which means the blue and the red. This blue and red is now labeled, okay? So this was the data, but now after labeling, you have two categories in it, blue and red. Okay. Some student can think that there is no word blue and red is written. Okay, don't worry. You can write or you can say color is the label. Huh? Color is the label. Blue and red. So this is the label data. And now you have your this model. So now you are you are training this model over this data, and now your model is trained. And then in the next step, you are giving unlabeled data. You are giving unlabeled data. It is neither blue, neither red. Your model is already trained. Your model is already trained on blue and red. It means that this model can detect blue and red from there. And in this data, you don't know which circle is blue, which circle is red, but blue and red are there, but unlabeled. So that's why it is mentioned with gray color, okay? But it means basically blue or red and there. Your model is trained. So then what? You will run this model over this data. So you will run this model over this data to classify these circles, either it is blue or not. And then what? Your model will give you what? The blue and red like that. So now this is the output. This is the output of this data. When your model will run on this unlabeled data, it is giving you this output, which you are calling it pseudo labeled data. Or now this data is now labeled by this model. Now you are doing what? You are using this new data, which is the output here, and you are using this previous data. And you are making a new data set, combined data set, okay? You are making a new data set, combined data set, and you are training your model. This is the same model, okay? Training your model again. You are training your model again. And then in this way, you can take further unlabeled data like that. And then you can run that model over it. That data will be labeled. And then you can combine. In this way, data set is also becoming large, and the model and the training of your model is also becoming mature and mature. So here you can say label data, unlabeled data, label data, unlabeled data. So mixture of supervised and unsupervised. So that's why it is called semi-supervised learning. Semi-supervised learning. So here we are just explaining this point that we use small amount of pre-labeled data, which is supervised, which is here, and large amount of unlabeled data, unsupervised, which is here, for training. Now, this semi-supervised learning is also explained here in 2 points. The first point we already discussed. This is the first point. This is the discussion of that model. This is the first. This is the first. First is displayed in previous figure. Build the supervised model on small amount of labeled data, and build the unsupervised model using the large amount of unlabeled data. Now train the model on pseudo and label data and repeat the process if needed. This is the illustration of this one shortly. So how we can implement this semi-supervised learning models. So the one way is this one which we discussed here in this diagram, and the other way is cluster similar data samples unsupervised. So in this diagram, the first data that you have is labeled. What happened if unlabeled would be the first data here? Okay, that is the other way, huh? So this is the model, but the data is unlabeled initially. Then what will happen? Because your model has now no any training and you are giving unlabeled data, then your model can do what? How it can separate them? So here it is classification too. Labeled data, it is classification. When your data is unlabeled and your model is untrained, then how you separate them? So this is clustering, okay? This is what? Clustering. So then you can use the unsupervised learning technique if the data is if the data samples if the data sample are unlabeled, which is unsupervised, then you can cluster them. When you will apply a cluster, it will make the groups. The output of the model would be what? The groupings, the clusters of the data. And then it will give you when you will give this data here to the model, it will give you this after running it. All red on one side, all blues on other side, clusters. Not like that. This is a mixture of red and blue, but it will red and blue. It will give you two clusters separately. And now, when you will have these two groups, label these groups. When your model will give these two groups, label these groups. One group is red, other is blue. Okay, label, and then use this information, these labeled groups. You now this is what? This is labeled data, huh? Now use this information to train the model further. So this is another way. So it means that when it will give you these clusters, red and blue, okay, then take it here now. Now it is a kind of a label data here, and now the train the model over it. And then you can take unlabeled data again and run the model over it like that as displayed in the picture. Now it would be okay. So the only difference between these 2 points is here the starting is with the labeled data and here the starting is with the unlabeled data. So you can also do something with the text, or you can also do something with the image classification or anomaly detection. So text and something like that. I can explain, but then I am on a recording, so that's why. Let's see that. This will not be in recording, huh? So if I will have some text here, this is the book and something like that. So I can say that this is what this is demonstrative pronoun. This is verb. This is determiner. This is noun. And in this way, I have all the data tagged or labeled. This is labeled. Huh? I am labeling these words with the part of speech. It is called part of speech. So if I have a file I have only written one sentence, but you can imagine that there is too many sentences in it. And this is a file, and the whole file is tagged. And now you have a new file, and in that file you have only sentences, but not these tags. Not these tags. So one way is, and this is your model. So one way is you can give this label data to this model, and this model will get trained on it, and then you can do this. You want this labeling also in this file, and now this model is already trained. When you will give this file, to this model, it will do what? It will produce with tags. Whatever the tags of the words, it will use this information and it will give you this file. This is one way. Other way is, so you can also do this. Other way is, you can give this data, and here these tags, here you were seeing only 5 tags, but when you will consider many tags, it could be many at least, but you can decide, okay, I am taking only 15 tags. 15 tags. So if you will give this and your model, you will have to do what? You can cluster them. How you can cluster them? Then you have to build features. Then you have to build features. But here, after taking this file without tag, then here you can use some dictionary. Here you can use some dictionary. From the dictionary, you can take the information and you can put this word in noun. For example, you can put this word book in the noun category. This is the book. The pictures in it are, for example, charming. So then I will say these pictures would be again from the dictionary. The category noun will be presented, and I will put these pictures also in the same group. So I will put book here and then pictures here. Similarly, all nouns will be in one category, and then another category, and then another category. So in this way, my model will get trained. Well, get trained when there are no tags on it. And this dictionary would behave like interpretation. And then my model will get trained over it. And after that, so now it is trained. Now I can give unlabeled data or whatever, and unlabeled data, and then this will automatically do that. This is one example for text. For text classification. The previous example was classification. This was not, okay? This is clustering, okay? The previous example, when the tags were there with supervised. So text and image classification. Similarly, you can do the image classification. So this is your model. You can give different images. Yes. For image classification, you can take this previous example. This one. You will give label data with the labels and your model, and then you will give the test data without labels, and your model will automatically train on this label data. And then when you will give test data, which you want to find what are these two images, and it will give you that this is a triangle and this is a circle. So this is an example of, this is a pictorial example of image classification. So you can do, when you will mix them, this is purely, this picture is purely an example of supervised learning, because we are not mixing We are not mixing labeled and unlabeled data. Okay. So now when you think over here, it is labeled and unlabeled. When you will mix, then it will become semi-supervised. When you will mix, okay? When you will mix, if you are not mixing, then either it is supervised, either it is semi unsupervised. So, so when you are mixing these two concepts, only then it is semi-supervised learning technique, and then you can use it on text, on image, or for anomaly detection. You can use it on any of your purpose. Now, reinforcement learning. Reinforcement learning. The students who already studied AI with me, okay, can we use image class?
Look, how we classify also like how we classify it's also supervised if we are looking for like image.
Classification is the category of supervised learning, okay? And if you want to classify using unsupervised, then you will not call it classification. Then you will call it clustering, okay? It is similar, but now it has a different name, okay? So you can classify by using clustering technique in the unsupervised. Because clustering is what? Separating groups. But it is from the raw data, not from the label data. Reinforcement learning. So the students who already studied AI with me, they know what is reinforcement learning, because in the agents, the last structured model of the agents we studied in AI was the reinforcement learning. Was the reinforcement learning. So in this model, what will happen? You will give the raw data. What is raw data? For example, here you are seeing stars and some raw shaped. So this is blue star, this is red star, and then this purple square. Huh? And it is a mix. We don't have labels here. It is a raw data. Raw means without labels. Okay, without labels. So this is the raw data. And what will happen? This data will go into this machine learning model. This is the machine learning model now. This data will come here one by one. One by one means this is one data sample. This is another data sample. This is another data sample. This is another data sample. Your model will check this data one by one. So one data will come here to the agent. It will come here. So one data entry is called now state. It will come to the agent. So the algorithm of this model will run over it, and it will suggest some action for that. That either it is a square or blue star or a red star. What it is, it will suggest some action. It will suggest the name of that date, name of that data sample, that either it is a purple block or blue star or a red star. That name is suggested by best action, but we normally use the term action. So then this will apply on the environment. What will happen? The agent will suggest that, okay, for example, if this data is coming, for example, if this data is coming, then the algorithm will run. It will suggest that it is a purple square, and then if it would be okay, then the agent will be rewarded with some points or whatever. It will be rewarded by any policy. But if your agent will identify incorrectly, for example, if your agent will identify this state as a blue star or a red star, then it is a wrong action, and then it will not be rewarded. It will be penalized, but it will be negatively rewarded. Okay, not positively rewarded. It will be negatively rewarded, and then it's so on, and this will go on for all the states. And then at the end, the output of the model would be the red star would be in one block or one cluster, and then purple square would be in another cluster, and this blue star would be in another cluster. I'm saying cluster because you understand what the cluster means. Okay. Otherwise, you can say the groups. It will separate all the data points, or it will, here in reinforcement learning, when we are using the term agent, then we can say these are all the states of the data, or these are all the data points of the data. And here it will be separated. So if your agent will do the right work, it will be rewarded positively. If your agent will do something not in a right way, then your agent will be negatively rewarded, punished, you can say. This is what, so reinforcement learning is what? It is a technique that teaches an agent. In this technique, or through this technique, your agent will learn how to make decisions, in the environment to maximize reward. To maximize reward means to maximize positive reward. Okay. To maximize performance. It's a feedback system where an agent receives reward from current actions. So if it will identify the state correctly, it will be rewarded positively. And if it will identify the state of from this raw data, it will identify the states with false value, it will be punished with the negative reward. This is what written here. And this is the diagrammatic illustration of this reinforcement learning. Okay, this one, if you will look over this picture, what it is saying, your agent is here, and this whole is the environment. Your agent, fire is burning here, and the water is on the other side. And your agent has to distinguish the this fire, and your agent is now thinking. First, your agent is observing, and then some policies or some algorithm is already coded. So that is in your agent. So your agent should have to select some action according to that policy. And for example, if your agent is going directly to distinguish this fire without water, then it is what? This action is not a good action. So that's why penalty minus 50 points. Minus 50 points. So action and get reward or penalty are here. And then, but from here, if it is the reinforcement learning, now with this penalty or with the reward, your agent will learn now next time if I have to distinguish this fire, then I should not have to come it directly. I should have to come it with the water. So it should have to go to the water first. So bad, next time avoid it. So bad move. So directly going to fire is a bad move. Next time avoid it. So this learning mechanism should be there in the agent, in the reinforcement learning. In the reinforcement learning methods, this mechanism would be there. And here it is bad, agent has learned, so it will update the policy, which is the policy for choosing the action. And in this way, it will iterate until this policy would be updated optimally. This is the same thing written here. You can read it by yourself. And I will start from here next, inshallah. It is almost finished, but what I will do, time is finished.